Hello, my name is Clinch, and this is my 15.1.12 term project, Proper Proofer. This program teaches users about propositional logic, allows users to build their own proofs in propositional logic, and can generate its own propositional logic proofs here. So here, users can learn about conjunction, disjunction, implication, and negation in propositional logic. And then, once they feel ready, they can begin building their own proofs. So let's prove that for any object, the object is either red or it is not red. Seems pretty simple and intuitive, so let's prove it. This will be a proof by contradiction though. So we will actually begin by assuming the opposite. We will assume that it is not the case that the object is red or not red, and aim to prove a contradiction from this. To write this proof, we will make one more initial assumption that the object is red. From this, we get the object is red or not red, and we actually already have a contradiction with our initial assumption over here. So we have proved a contradiction, but we can't just prove it from this branch. We must combine it with this branch over here to prove this contradiction. And we assumed red and proved a contradiction, so therefore it must be the case that the object is not red. But once we prove that the object is not red, we have proved that it is red or not red, which still contradicts our earlier assumption over here. So we combine them to prove another contradiction. Now our only assumption was that it is not the case that the object is red or not red. We proved a contradiction from that, and therefore it must be the case that the object is red or not red. So there is the law of excluded middle for redness. And now let's move on to the final feature of the program, automatically generating proofs. So let's say we had a propositional statement that we wanted to prove, but we didn't know how to do it. Well, the program can generate its own proof for that statement. So let's say we want to prove that for any object, if the object is not red and blue, well, then that implies that the object is not red or it is not blue. And the program will actually then generate its own proof of this. Here we can see its proof. We can go down the proof step by step using the arrow keys. There's the proof in its entirety. We can go backwards in the proof using the arrow keys in order to better understand the proof. And this proving system is actually capable of proving any logically valid propositional statement. So those are the major features of my term project, Proper Proofer. Thank you.